Here's an example of an application problem. We wanted to find the maximum volume of a rectangular prism. So I just pulled this from a textbook problem on page 132. We have an open box. So this top right here does not exist. And it's made from a square piece of material. So we have a 36 by 36 square. So here's our square 36 by 36. And what we do is we want to cut an equal square length x and then turn it up. So this piece x is going to be gone, it's going to be gone, going to be gone, going to be gone. And what we want to do is come up with some questions that revolve around this rectangular prism. So I did is I took away an x and an x from this side, so now I'm left with 36 minus 2x. And then I recreated this flat piece of paper in 3D. So here is my height that I took out of the box. And then each side that's left is 36 minus 2x and 36 minus 2x. So this would be like my length and my width of my rectangular prism. Question 1. If we want to find the volume of this rectangular prism, what can we fit inside the box? I put the volume formula that you've learned in geometry. Volume equals length times width times height. How can we create this as a function? So we're just going to multiply these three red pieces together. X, 36 minus 2x, and 36 minus 2x as a function. So we say v of x equals the length, the width, and then the height. So here it is in factored form. If we wanted to take the time to FOIL it out, distribute it out, and get it into a cubic function, we could do so. Next we want to do is find the domain of this function. Remember, if you have a cubic function, the shape is going to look like a snake. So we have some parameters for our domain. So I'm going to set each of the zeros, 36 minus 2x equals 0, and x equals 0. Remember, these are both repeated functions. So I'm going to add 2x to both sides, and then divide both sides by 2. So 36 divided by 2 is 18. So I have an intercept of 18 and an intercept of 0. So if I just kind of create a little sketch first, if this is my x-axis, which represents the height of the box, sort of the dimensions, I have an x-intercept of 0, and then I have another one at 18. So my domain has to be somewhere between 0 and 18. All right, let's go on now and find the maximum length of this box. We want to identify the dimensions of this box. So we're going to create that graph. So we're going to graph this function. So you can use your graphing calculator to give you a sketch of it. I'm just going to go ahead and bring up mine. It'll take a couple minutes to bring it up. Okay, it's starting to come up. All right. Go ahead and turn your calculator on if you have one. We want to clear that y equals, so go to y equals and clear it out. And we're going to enter in this equation, 36 minus 2x, an extra x there, and then 36 minus 2x, and then x. Start to graph it here a little bit. My window, here are my values right now. If I go from 0 to, let's say, 300 on my x, actually 820, sorry, I want to do that for my y. So 20, scale of 1, and then the y minimum, we'll just do negative 20, and then y maximum, say 400, and then scale of 100. So what you'll see is the start of this graph in this window. Looks like I need to go higher on my y values. So I can go back to my window, change my y maximum to maybe 1,000. Still not big enough. So go back to the y. Let's do 4,000. All right. Here's what our graph looks like. It's a snake. Kind of coming up and going back. This is what the snake looks like. Remember, this was 18, x-intercept, x-intercept. What we want to do is trace with the graphing calculator what is this maximum point. So we'll just go back. I'll teach you how to do that with the graphing calculator. You push trace. And you can scroll with your cursor. And it looks like it's about 6. That's that highest point on the graph. So this highest point, here when x is 6, we're going to evaluate the function when it's 6. So we say 36 minus 2, 6. 36 minus 2 times 6, and then 6. And this will give us our maximum volume. Our maximum height is going to be 6. So now simplify this to get our maximum volume. 36 minus 12. 36 minus 12. 36 minus 12 is 24 times 24 times 6. Which is 3,456. So this point right here, this maximum point is 6, comma, 3,456. So it asks us to find out the dimensions and the length. And we are in inches. So if I draw this picture of this rectangular prism again, our x is 6 inches, and then these two were 36 minus 2x. We have to substitute x in. So 36 minus 2, replace the x. 36 minus 12 is 24 inches, and then this one is 24 inches. So the dimensions of this prism, length, width, height, is a 6 by 24 by 24. That'll give us a maximum volume of 3,456 inches cubed.